In this training video, we will discuss how to perform CFD simulation using Solidworks. So I had been using this module in teaching CFD simulation. So even in this uh, today's version for Solidworks, this module still works because we will browse the examples for latest Solidworks version. You can see still this is the example being used. So to start, in order to for us to have the basic know-how of CFD SolidWorks simulation, so I think this is the best module that we could use. So to start, we will perform the ball valve design. So a ball valve design is where commonly water flows from this side to up to this side and being controlled by the ball valve through turning. Okay. So using this tutorial, we will deal with the flow of water through a ball valve assembly before and after of some design changes. So to start, we should open the SolidWorks model. So we don't need to draw it. As I have said, there's already a save file when you install your SolidWorks software on your PC. So you just need to access it on the Drive C program files SolidWorks Corp and go to the SolidWorks Flow Simulation, access examples, and you will see this ball valve up to the electronics files. Whereas if you will open the examples, you could notice that these are all listed in this module. Okay, so that's why still updated, still the same lecture that we could use to perform CFD simulation. There you go. This one, hospital, right? Okay, so let's go back to the example, ball valve. Okay, now we will open the file ball valve. So I have already saved it on my desktop. I'll just need to open this. Okay, so make sure this is an older version, you save it. So notice if your SolidWorks is the latest. Okay, so these are the parts of the ball valve assembly: your handle, the body of your model, and the leads. Okay, so the leads are generated when you're doing CFD simulations for internal, but this one is already been drawn and prepared using this model. Okay, so the ball valve simply, if you turn the handle, so we need to suppress it, the mating of the ball valve, in order for us. So as you can see, it is slightly turned, wherein the water will flow to this here, and it's slightly restricted for the flow. So if you want to block totally the water flow, you need to rotate it about 90 degrees. So as you can notice, there's no more hole for the ball valve. So there's no more way for the water to pass through. Okay? So that's the function of the mating. So unsuppress so that it will go back again. You can see there will be a flow of water because the ball valve is slightly open. Okay, so let's proceed. So once we have opened the file, we will go to proceed in creating a flow simulation project. Okay, any CFD simulation will have to start by opening the project wizard. So this is the project wizard toolbar. Okay, so let's go to the upper left, open the project wizard. So as you will notice, this is the wizard project name. So we need to rename it in order for us to know what is our current project. So next. So next is to specify the SI units. Okay. So there are various types of SI units that we could use. But for this example, we select SI. So as you can notice, the main HVAC are already set to SI units. So the main Pascal, Kelvin, second, meter. Okay. Next. So for this simulation, we will keep the default selection, which is the internal, and we will not include the physical features of the pipe. So if we don't include the physical features of pipe, then we will exclude cavities without flow conditions. Once we uncheck this, we need to specify the roughness of the wall of the pipe. Okay, so if you don't care about heat conduction, radiation, time dependent gravity, rotation, you need. Okay, and then we click. What we will do next is we'll go to the type of fluid that we need to select. So click next. So since the water will be used, so we'll select liquid, then select for water, add. So if it's not stated, we don't care about, we just leave what is leave as default. So we'll leave as the laminar and turbulent flow. So notice we could add some fluids or material or any fluids that we could use. If it's not stated here, we could input as long as we could provide standard parameters. Okay, next is if we don't care about heat transfer, we'll just keep the default to adiabatic. So just leave it to adiabatic, and roughness if we don't care about, we'll leave it just as default. Then lastly, on the project wizard is we have to set the initial conditions. So this one is very useful if we know where will the simulation will be near on its starting point. So in order to fasten the simulation, but if we don't know it, we just leave it as from 0 default. So standard atmospheric pressure. So we need to accept the default for the result resolution. And finish. Okay, so first is this is the computational domain. As you can see, since we have selected the internal simulation, so it just care about this point. Okay, so first is, as we discussed, that we need to select the mesh. So we need to right click and select the mesh. So this one is already set to level 3, so just leave it here, but we need to specify the minimum gap size to 0.0093. So meaning that beyond or smaller than this, we don't care about. So we need to specify it if we are particular with the gap size. So we have to select manual specification of the gap size and set to 0.009 meters. Okay, so select this and 0.0093 meters. Okay, and 1. Okay, and once you're done, just click save in order to save your recent activities. Okay, we are already done specifying the minimal gap size, so meaning that this is the minimum gap size that the Solidworks will consider. Okay, So I have already discussed the computational domain. We could already hide it. Then we need to specify the boundary conditions required where fluid enters the exit or entry point of the model. So we could specify pressure, mass flow rate, volume flow rate, or velocity. So first, we need to have the input data. Right click, insert boundary conditions. Okay, so first that we will need to set up is the input. So what is stated here is we need to specify the inlet mass flow. So notice he discussed about select other. So this is one that we will do. So we have to select the inlet mass flow and input 0.5 kilograms per second. So inlet mass flow, and we need to select the inner side of the simulation. If you select the outer side, it is not stated or it is not considered in the computational domain. So we will have an error. So we need to right click on the face of the lead one, then select other, then once highlighted by the orange part, this one is the right lead face that we need to select. So as you can see, there's already the inlet mass flow value. So as stated is 0.005 kilograms per second. Okay, then there's, as you can notice, there's thermodynamic parameters, but since these are not stated in the document, we leave it as default. So they will use the standard parameters for the thermodynamic parameters. So that's default. Okay, so there's already the arrow pointing to that direction. Then we need to specify what comes in must comes out in order to have a flow. So using Solidworks, we'll select lead 2 again and select other and insert boundary conditions, and we need to select the pressure openings and static pressure. So since this is already connected to a pipe, we will use static pressure, not the environment pressure. So insert boundary conditions, then environment pressure. So since we will assume that it will go up at this certain pressure, so we need to close the lead or select the lead rather. Select the lead, select other, then select if the face of that lead is being selected. So what is the pressure stated here? So we leave it as default. Okay, that's stated. Alright, so once we have this one, we have the inlet and outlet. Okay, so in, out. So there's already a flow. Okay. Now let's specify the engineering goal that we need to have after doing the CFD simulation. So first is pre-select the inlet mass flow one. So in order for us not to select the face lead anymore. So pre-select, then go to the insert surface goal toolbar and select inlet mass flow 1 and select the static pressure average. So inlet surface goal. So as you can see, the face of the lead is already selected without doing anything. So let's select what are the parameters that we are looking for. Forgot. So static pressure. So static pressure. Static pressure is above. Okay. Select average. So we will have the SG AV static pressure. Okay. I think we are already done putting out our first CFD simulation. So click save, and we could run the simulation using right click on the ball valve name, run, or this one. Then you can see this is the solver. So we need to do a mesh again, solve new calculation, then run. So as you can see, this computer will use all its resources. Then solver will prompt up to do the calculations for you. So there's already event time, and you will just wait for the solver to finish. Okay, I'll just stop the simulation and wait for the solver to calculate. So notice there is already warning vortex pressure opening. It's common for this when we prepare our simulation, usually for CFD. So it's just okay, and okay, there's done. Solver is already finished. So I can see that we ran 40 iterations and has been finished about how many seconds? About a minute. Okay. So once the solver is done, close it. Then we already have the results. So let's highlight this one, open it. So what is the first activity once the solver is done? Okay, so let's first adjust the model transparency. So the model transparency for this one is 0.75. So let's go to the model transparency. Look for the eyeglass. Adjust it. Alright, so the model is 75% transparent in order for us to clearly see the fluid inside the ball valve. Okay, so let's try it. Cut plot. So insert the right cut plot and click insert, then select plane 2 in order for us to do this simulation. Okay, so right click, insert. So in order to do a cut plot, we need to select a plane or a side in order to project it. So for this simulation, we need to see the cut plot the way that we want it to be projected. Okay, so let's select plane 2. So surfaces. Oh, sorry, I clicked surface plot, so we need to select cut plot. Sorry for that. So I missed this one, so I need to change this to plane 2. Contours. What we are particular of is the pressure. So let's go to the pressure. Number of points is not stated, so we'll just leave it as default. So this is the number of points that I'm talking about, wherein you will have to make it a detail, more number of levels. So just leave it at default. Okay, so this is our cut plot results. So this is how the pressure varies from the entry point to the exit point. So as you can notice that we have lesser pressure upon entry, then upon passing through the ball valve, the pressure increases. So there's a Venturi effect happening. Okay, so let's select the vector. So right click, edit definition, and select vectors. So once you select this, okay, we have this a series of arrows flowing from the entry point to the ball valve. Okay, you see how the fluid flows. Alright, So let's hide the cut plot, hide it. Then let's proceed with the surface plot. So insert. So you have to select all faces to do the surface plot. So select the all faces, and Solidworks will do the selection for you. And what are we gonna find is click OK, and we need to have this model. Alright, so this one, we have this surface model. So the difference between a cut plot is a cut plot is pertaining to a certain plane, while a surface plot is pertaining on the surface that you selected. So this one, we care about all of the surfaces inside the simulation that we have done. So you can see the full 3D version of this surface plot in terms of pressure, or we could try the velocity index. So I selected velocity index, this one. So the problem with the cut plot is okay, if we're gonna use a surface plot, we just only see the outer wall, while if we will use cut plot, we can see the inner, what is in the middle or in the selected plane. So we hide it. As you can see, that is more of detail of what is particularly on the middle of the simulation, which is the way we want it to see. So you can see that we have this negative velocity here. So we have an increased velocity of from 1.71 to 7.746, and gradually slow down again upon exiting. So that's how the flow happens. Okay, so let's go back again. So we need to view isosurfaces under the value 1. So right click isosurface, click insert, and keep the default under value 1 and read OK. So how is that possible? So hide it, hide, and isosurfaces. So what value are gonna use? Pressure again, combine number of levels. So keep the default under value 1, under appearance, select read and OK. And check this one. Alright, so since this is a new version, that type is not already applicable. This one is how we will do or show as isosurfaces. But normally I'm not using this one. So I just hide it. I don't like the isosurfaces. So let's proceed. Okay, this one is my favorite. Viewing flow trajectory. So first is we need to select lead 1. So particularly the flow will start in lead 1 but not in lead 2. So just select this one, then use insert. So I'm not using the lead 2 because this will conflict on the way we do the simulation. So I'm just using where is the input of our fluid. So just use 20 as our number of points. So use pipes, could use lines and arrows. So first we use pipes. So select this one. Okay, so this one, you can see this is already the flow, or let's go to the pressure. Okay, so actually we can do the animation here, play it. You can see that we have an increased pressure, and what happened? Oh, alright, stop. Alright, so when we look for our velocity in x, total velocity, you see that we have a slow velocity and gradually increases, but we just deal with directly on the direction velocity in x. Just like almost no change, so we just play it again. Alright, so we could simulate how the fluids flow in terms of pressure and in velocity. So I think to make a new visualization for that, we will use spheres, or we could use lines with arrows. Alright, so play it. Okay, so using this one, we are now doing a CFD simulation for our first simulation ball valve. Alright, so if you care about pressure, let's change it. And we could also clearly demonstrate how the fluid flows inside the pipe. Okay, now let's move on. So just get this one. Okay, so I will not tackle all of this one. Okay, so I will perform this on our next training video. See you again.